Oh, wait, yeah, you do.
Okay, so a Venn diagram, the middle of the Venn diagram, things that are the same, that meet both of these conditions, or things that are similar to both. And if they're outside of that intersection part, it's only in a numerical expression, or in this side, it's only in an algebraic expression. Okay? Tori can't cheat because she has it printed out already, so does Olivia. Maybe some of you saw what it said. All right, so first, a variable, right? A variable is a symbol. Most of the time we use letters. In 7th grade, we'll use all just regular letters. Okay, but later on in advanced science and math and stuff like that, you'll use things that are not letters. Well, you use Greek letters for a lot of variables. You could use, back in 3rd grade, you used a smiley face or a shamrock or a heart, right, for unknowns. Those were the same as the letters we're using now, okay? A variable, a symbol that represents an unknown or changing number, okay? An algebraic expression is an expression that has variables, operations, add, subtract, multiply, divide, exponent, and numbers, okay? Contains variables, numbers, and at least one operation.
But don't we need to know what n is?
No.
What?
You don't. That's the thing about algebra, is you can use this letter to represent something you don't know. Now, sometimes you'll figure out what n is. That will be solving an equation, which is the next unit. Sometimes you don't care what n is. It's something where you want to be able to plug in different numbers in for that variable. That's what we're doing in this unit. Okay, most likely it's going to be, hey, what happens if you put this number in for n? What do you get? What happens if you put this number in for n? What do you get? Okay? All right, so what things are in both numerical expressions and algebraic expressions? What things are in both?
Plus signs?
Operations, so plus, minus, division, okay? And also, what's in both?
A letter. Or number.
Okay, letters are not part of numerical expressions. What? Numerical means it has numbers, just numbers. Algebraic means it has numbers and letters, okay? So it should say in this box, and I don't even know what it says. Does it say numbers in this box? No. No. Well, I guess that's true. You don't have to have numbers in an algebraic expression. It could be just letters and operations. That's true. Okay. So both of them have to have a plus, a minus, a division, or multiplication. What if it has no operations in it at all? What if it just looks like this? Thanks. What if... Stop laughing at me, Olivia. What if it looks like this? Yeah, there's an operation in this expression. It's multiplication, because when there's nothing there, it means to multiply, right? I think it says that on the next screen, actually. Okay, so what's in an algebraic expression that's not in a numerical expression? Variables, okay? Variables, okay? So, yeah, I see what's happening here.
What?
So variables and numbers go in this side, okay? Because algebraic expressions have variables and numbers. Numerical expressions only have numbers, okay? So that's the difference. Okay, so here's an expression down here, f minus 32 times 5/9. That's the formula for converting Fahrenheit temperature to Celsius temperature.
There's an actual box here.
Yeah, I know. This is the only one I missed, I think. Oh, did I remember to hit save? I don't think I did.
But wait, these are out of the book, though.
What do you mean they're out of the book?
Like, you copied them from the book, not from your screen. So how are there, like, actual boxes?
Well, I take a picture of the page from the electronic textbook and I make a slide from it and I put the boxes over top. That's how I make all my presentations.
We do have to round these notes.
You can write in your book these things if you want to.
I didn't have my book.
you have the notes page right in front of you that has all the pages that are in your book. So you could do them now. Then when you go get your book, you could copy them over. You have a pencil?
No.
Yeah, because you came from not real class, right?
No.
Uh-oh, last pencil.
Wait. Wait, I thought last pencil was one pencil though.
What?
Last pencil was one pencil though. I asked you to give me. How is this your last pencil? I asked you. Thank you.
You're welcome. Okay, so in this expression, f minus 32 in parentheses times 5/9, the variable, what is the variable in this expression? F. Okay, so Olivia, or Tori, you're gonna have to stop calling out answers so I can give other people a chance to answer. I appreciate your enthusiasm, I really do.
We don't look like each other.
What?
You called her Tori. I mean, you called her Olivia.
I know, I got it. All right, so F represents the temperature in Fahrenheit, which you get to pick that temperature, and then you can evaluate this expression and figure out what the Celsius temperature is, which we'll probably do on an example later on. Okay, so here is more vocabulary. I think these are all terms that you have already seen, okay? The branch of mathematics that involves expressions with variables, right, letters in them, is algebra. In algebra, the multiplication sign is almost always omitted. As you get into, and I've told you this before, we do not use the X for multiplication if we can avoid it. Okay? So you write multiplication with nothing in between letters, numbers, letters and letters. Okay? So 6 times D, 9 times S times T, M times N. A to the third means A times A times A. Okay?
I don't know what it is.
What?
That's why I'm confused.
You don't know what the letters are?
How are you supposed to know what the letters are?
You don't. You don't need to know what they are in the beginning. You'll find different kinds of problems where they'll tell you, which we're going to do in a minute, M is this number and N is this number. What does this equal? Okay, that's part of today's lesson, a main part of today's lesson. So you'll see. Okay? The numerical, the number that variables are multiplied by is called the coefficient. Have you heard that word before? Anyone? Does that sound familiar to you?
No.
Coefficient? I'm pretty sure you got it last year, but maybe not. Okay, so the coefficient in this expression is,
Times. D.
6. The coefficient is the number that a variable is multiplied by. The coefficient in this one is 9. The coefficient in this one is, well, it's not none, it's invisible. What is the number in front of this, the number that these variables are multiplied by? 1. Was that you? Yeah, 1. Okay. This is the same as 1 times m times n. Multiplying by 1 doesn't change anything, right? It's always invisible. Right, Nick, if you want your answer to be, oh, he's listening to his lesson. We were just talking about this in accelerated class. Okay, there's an invisible 1 in front of variables if there's no number there. Okay, all right.
Mr. Riley,
Someone ask a question?
That was Carlos.
Yes?
my dog is like weird outside into the woods. Can I go find him for like 5 minutes?
Carlos, you can do whatever you want because you're at home.
I'm
So-
sorry, I don't know where he is.
Well, go, are you the only one home?
Yeah,
All right, well, go do what you got to do. Get back as soon as you can.
I will. Thank you.
Yep. Division. We've talked about this also, right? That okay, I moved this onto a different page, but we'll talk about division in a minute. I guess I'll skip it over here. Okay. Division in expressions is normally written now, from now on, as a fraction like that. We really don't use division signs too much. Okay, realize though that this y over 2 like this is also the same as y times 1/2. right? Dividing something in two is the same as multiplying it by a half. You'll see that more later on. Okay, so what do you have to do in this unit, this topic today? Well, the main thing we're going to do is what's called evaluating expressions. To evaluate an expression means to substitute in numbers. If it's an algebraic expression, it has variables in it. Substitute values in for the variables, and then simplify using the order of operations to as small of a number as you can get. One number, these will get, okay? So that's evaluating an expression. So you start with an expression that has a variable in it, 2 parentheses n plus 3. Okay? And they're going to tell you what value to put in for the variable or variables in the problem. In this case, they want n to be -4. So the first step, which is a required step, you have to show this step in your work for every problem like this, is to substitute -4 in for the variable, right? The variable here is Mr. Riley, but this is saying, hey, Miss Makahovsky is going to be substituting for Mr. Riley, so we're going to put her in instead. She replaces me, okay? That's substitution, okay? So you substitute the number in for the variable, or variables if there's more than one. They'll tell you values for each one. Now you have 2 times, and a lot of times putting this variable in parentheses is a really good plan, okay? Now sometimes it gives you multiple parentheses like this, but especially if it's a negative number, putting that number in parentheses, good plan, okay? Now you have all numbers, a numerical expression, now that you've replaced the variable, and now you can use the order of operations to get this down to one number. The order of operations, remember, operations in parentheses first, then exponents, then multiply and divide left to right, then add and subtract left to right. In the sticky on the side of the page here, okay? So there's parentheses here, so the first thing you do is add in parentheses, -4 plus 3 is -1. Then you do multiplications and divisions, 2 times -1 is -2. That's your answer, okay? Another example, this one has 2 variables, W and V. W is 5 and V is 3. Substitute in, see here how they put them in parentheses. That way you don't have to put multiplication signs in here, right? If you put your number in parentheses, 8 parentheses 5 means 8 times 5, which is what this means, right? 8 times W, if W is 5, means 8 times 5. So now, order of operations again, there's no parentheses or exponents in this problem. You'll say, Mr. Riley, there's parentheses around the 5. But there's no operations inside there for you to do to simplify the expression. So 8 times 5 is 40, and 2 times 3 is 6, so it's 40 minus 6, which is 34. The reason I circled this step in the middle, if it's an easy problem, is optional. You don't have to show that work, okay? Typically. Now, some of them you're going to want to show that work. Many of you should show those steps, okay? But I guess I wouldn't take off points if you didn't show those steps. That's really what it is. Okay, last one. 4y to the third plus 2 if y equals 3. So again, I substitute in 3 instead of y in parentheses. The exponent here only works on the y. It's not 4 also raised to the third power. 4 is not raised to the third power here, just y. So that means 3 to the third power is your exponent operation, which you have to do first. 3 times 3 times 3 is 27. Then you do multiplication and division. 4 times 27 is 4 times 20 is 80, plus 4 times 7 is 28, is 108. Plus 2. You really should not be using a calculator in this unit. However, I will tell you there are some big arithmetics like this one. If you wanted to do 4 times 27 in your calculator, okay. Don't put the whole thing in your calculator though, because then the calculator does your order of operations for you and you're supposed to know how to do that. But I won't enforce too much until in 2 weeks when everyone's here, then I can require whether you have a calculator with you or not.
What do you mean?
Because I can see whether you're using a calculator or not when everyone's here doing a worksheet instead of everyone being online. Questions?
Yeah, I can do that.
Okay, well, when I get to it, I'll tell you what I was going to talk about letter D. So letter A. Letter A.
I didn't finish.
Okay.
Man, that's easy.
8 minus 3, right? Substitute 8 for C and then subtract. Letter B, 15 minus 8. Substitute in 8 for C.
Oh, hey, right.
And the answer is 7. All right, number C. Now it starts getting a little more complicated, right? Here's how I suggest you start this type of problem. 3 times plus, write out the expression without any variables in it. And then substitute in for each variable. And if there's a lot of negatives and stuff going on here, you can put them in parentheses, okay? So I'm going to do it in a different color because I can. C, right? C is 8 and D is -5. That's the substitution step. Now you don't have to put these parentheses here. If there was multiplication, you do have to put them there. Okay, we'll get to that one in the next example. So it should look like this. 3 times 8, and now look what I did here in the 8 minus, oh, sorry, that is 8 plus -5. Never mind. Order of operations, parentheses first. Okay, so 8 plus -5 is 3. Then multiplication, 3 times 3 is 9.
Oh, I did that word. Oh.
All right, give me some answers for letter D. What did you get for letter D? -4 is one option. Anyone get something different than -4? 36. Uh-oh. Anyone get something different than -4 or 36?
I didn't get that far yet.
No? Everyone's got one of those two things? People at home? Okay. Let's see what happens here. So first, 2C minus 4D. Now, be careful. One person out there I saw wrote this. 2C minus 4D. It looks like that.
It's like 28 minus 4.
This looks like 28 minus 4 minus 5 to me. Does it not look like 28 minus 4 minus 5? Okay, so this is not good. That was just putting in, they just substituted in the numbers in for the letters. You have to. All you got to do here is use parentheses. When you substitute in numbers for letters, if you put them in parentheses, now it doesn't look like 28 minus 4 minus 5. Now it's 2 times 8, like it's supposed to be, 2 times 8, and 4 times -5, like it's supposed to be, and subtracting those in between. Okay, so then multiplication and division, there's no parentheses. These parentheses don't count as parentheses. There's no operations inside of them for you to do. So you multiply 2 times 8, and then 4 times -5, and you get 16 minus -20, right? Which is the same thing as, same change, 16 plus +20. Okay, this is why people got -4. They messed up the positive and negative number part. Okay, Pixie's raising her hand.
Yeah.
You have a question, Pixie?
I thought you said it wasn't 36.
I didn't say it wasn't 36. I just was asking for answers.
Oh, okay.
I didn't know what the answer was, actually.
I always mess up with that. You need the name with the answer is.
Yeah, so positive and negative number rules, which we learned back in October, right? You're going to use them all the time for the rest of your math career. You get plenty of time to practice them. And subtractions will mess with you until you're in pre-calculus as a senior in high school. Just the way it is. Okay? All right, letter E. Oh, now this one has an exponent on it. Okay? So with an exponent, again, here's what I'm going to do. I'm going to do parentheses, minus, parentheses, and an exponent. Okay? This is letter E. Substitute, I'm putting in parentheses instead of the letters. And then I can substitute in D is -5. And C is 8. So that's my substitution expression. Parentheses especially useful around negative numbers. You could get away with not putting them in anywhere on this one, I suppose. Okay. Now order of operations. Again, these parentheses have no operations in them, so they're not really there. They're just there to keep the number kind of separate. So I got to do exponents. 8 to the second is not 16. It's 64 because that means 8 times 8, right? So that's -5 minus 64. Keep, change. Did you get -69 on this one, Jasenia? Yeah.
I got 59. Oh, what the? I don't know what I did wrong.
You didn't keep, change on the
You
subtraction,
have to do keep, change with the same.
right? If you have a subtraction of positive and negative numbers, you're in 7th grade, so this is what you get.
Not helping.
-69. Keep, change. That's what you did right here. Okay, this from here to here, same, change, because it's a subtraction. Last one, oh, the most complicated one, 2d squared plus 5d. So again, I'm going to write 2 parentheses squared plus 5 parentheses. And then inside the parentheses, I'm going to put the value for d, which is -5. These parentheses right here are absolutely required. If you do not write these parentheses, your answer is wrong. Negative numbers with exponents must be in parentheses. So d squared, which is supposed to be -5 squared, the -5 must be in parentheses. What's -5 squared? Positive 25. Because it's negative times negative, so the answer is positive. A very, 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 very common mistake, even with advanced algebra students. Okay? People make that mistake all the time. -5 squared is positive 25. Because negative times negative is positive. Okay? So 5 times -5, that should be plus negative here, right? Is plus -25. Okay? So 50 plus -25 is 25. Okay, that one is tough. That's the hardest one, obviously. Okay? What? Okay. You will have the completed notes available to you later today, right? If you miss anything, like always.
Hey!
You know, I almost always post the completed notes, and if you ever notice that I didn't, that I forget to, please remind me by email, like, Mr. Riley, you didn't post the completed notes from today's lesson. Give me till the end of the day, right? I do it during my prep typically. Last block on blue days. Okay? Any questions on this? IXL T56 is problems like this. Practice on these kinds of problems, plus some of the practice problems in the book. Okay? In IXL, you have to get an 80 on that one.
What about X and
The other one, I think you have to do 8, maybe 10, which is these kind of problems. More difficult than those,
No.
Okay, because now we're going to talk about real world problems and algebraic expressions. Okay, that's the problems in the book. The class cake is the problems in the book. All right, so a formula is used all the time. You've been using formulas since you were in second grade, probably.
I already did T5.
Yeah. Oh, that's true. Some of you, I think we already might have done this in a separate at a separate time. Or maybe you did. I forget. Okay, a formula is very important in science, in business. There's formulas all over the place. Can anyone tell me a formula that you know? Formula for something, for finding. How about the formula for the area of a rectangle? Length times width. That's a formula. Okay, to calculate the area of a rectangle, you have two letters that represent quantities that can change. This page is not in your book, okay? Geometry is the most commonplace at this point in your life that you have used formulas, okay? The formulas for area or perimeters of geometric shapes. Variables are almost always used in formulas to represent the things that can change, the measurements or the quantities that you're going to put in to figure out something else, okay? So you substitute the values that you know, and then you can calculate whatever it is the formula is trying to tell you. So it's the same as what we just did, except the variable expression might be a little more complicated, like 3 times 220 minus a divided by 5. It says here, it'll tell you, a formula has to tell you what the letters represent. In this case, A is the person's age, okay? So to find your minimum training heart rate, it depends on how old you are, and you put your age in and then you calculate it, okay? So the steps are the same as what we just did. Substitute, that's this step. Put the number in for A if you're 15 years old. Then use the order of operations. Inside the parentheses, this comes out to 205, then you multiply. Now this fraction bar is a division symbol. We said this during the whole fraction unit too, that the fraction bar is a division symbol, okay? This 27 over 3 is the same as 27 divided by 3. You might notice that the division symbol is actually a fraction bar with dots on the top and the bottom, representing the division of these two things. Okay? From now on, you're supposed to use a fraction bar for division and not an elementary school division symbol. Okay? And if it's the other way around, like if it was 2/5, right? You're like, oh, 2/5, that's a fraction, right? But that's the same as 2 divided by 5. And in your calculator, that comes out to 0.4. It's a division, even though it's a fraction. Fractions are division from now on in your life. Okay? So, here's a couple guides. To find the area of a triangle, 1/2 base times height or base times height divided by 2. They're the same formula. Where B is the base and H is the height. Can anyone tell me what has to be true, if you remember? What has to be true about the base and the height of a triangle when you are using those measurements to find the area of a triangle?
What page are we on?
Well, they have to be the same units for sure. They both have to be inches or they both have to be feet. This is on page 351. Sorry, page 351. We'll do this one together. Okay, so here's a triangle. And let's say this one says the height is 6 and the base is 8. if this is 8, is this 6, this side of the triangle? That is not the height.
The height is an imaginary line.
Right. What has to be true about the base and the height in a triangle?
Number?
Not even numbers. They have to be perpendicular or make a 90-degree angle, right? That's the relationship of base and height. This is a geometry topic, not for this current unit, but, and this can't be 6 if this is 6, right? It has to be longer than that. The actual answer would be what, Diego?
What?
He was listening.
This is the base is 8 and the height of this is 6. No, you can't do it. Never mind.
What page are we on?
Page 351. Oh, the bottom one there. You see it? This triangle could also look like this. If it was this kind of triangle. Then this could be 8 and this could be 6. That would work also. Okay? Got it, Kathy? Oh, sorry, you want me to do it? No, let's say, all right, what does the substitution step look like in this problem? 8 times 6 over 2. How am I going to write 8 times 6 over 2? Well, yes, in fraction form, but how am I going to write the 8 times 6? 6 or both in parentheses, not with a multiplication symbol, okay? I put them both in parentheses. You can put just one of them in parentheses, okay? This bugs me, right? I teach later advanced math courses because this X looks like an X, a letter, not a multiplication symbol. That's why we don't want to do this anymore, okay? Not like that. Okay, 6 times 8 divided by 2, which is 24. So my answer is 24 inches, okay? Square inches, sorry, because it's area. Area is inches times inches, so the units is inches times inches. It's actually squares, okay?